now we're going to move into that human exploration endeavor. We have Jake Bleacher from ESDMD and Sarah Noble from SMD. I think most of you know them all, but they're going to share some updates on Artemis, the planning, where we're going, the community, and just to tie this all back, this is the focus of survey. Science enabling exploration and exploration enabling science. And so we really want to have both organizations provide you with an update, and they're working closer than they ever have before to pull all this off. So with that, I'll talk another minute. No. Jake Bleacher is going to come up as soon as our tech team finalizes something with him. And then Sarah will be joining us virtually today.
All right. It is really good to see everybody out here today. It's been a few years. Never ceases to amaze me the immense adrenaline kick you get walking up on stage like this in front of everybody. We just talked to some of our early career colleagues this morning, and just want you all to know that it is not a negative to have a rapid heartbeat and wobbly knees when you get up here in front of everybody. You could talk about that as being nervous, I guess it is, but it's also excitement. And so what I choose to focus on here is the excitement of what we're talking about. Why are we excited? Well, because of this. I liked Greg talking about JWST as he opened up the session. It's great. We're looking farther than we've ever seen before. Humankind is trying to understand our origin, our place in this evolving universe. But we also have this immense opportunity to look at our nearest celestial neighbor in more detail than we ever have before. This is the library for us to understand our place in this universe. We can look back in time with JWST and Hubble. We can do the same thing by traversing around the moon, whether that's robotic or with astronauts. This is why it's exciting. And I want to leave you all with that today. I hope that should be a common theme. Another theme that Sarah and I talked about and joked about, maybe I should make it my title, is this is getting real, okay? That is something that I do want everyone to carry away from here. The opportunities are coming. Sarah will talk about some of those as well. What I would like to talk about today is how we're getting science built into the architecture. But again, I know that those of us who do this day in and day out and are buried in it, it might seem more real than it does to everyone else. But I do want you to take away from today this message that this is becoming real and we are going to the moon. And the opportunities to participate will be present, and we hope that you all will be a part of that. Now, as many of you know very well, it's been a little bit chaotic in the world of human exploration over the last several years. I believe it was early 2019 when I first heard Bill Gerstenmaier reference a reorganization. I think we're finally at the place where the dust is settling and we're really getting ourselves stabilized to move forward. This is an org chart that's online. I don't want to destroy everybody's soul with org charts, but I did want to let you know where we stand right now. So I work within the Exploration Systems Development Mission Directorate, and I'm in an office called Technical Integration Office, which directly supports Jim Free in the Office of the Associate Administrator. We're working to ensure that we have an architecture that's integrated, and our job is to make sure that we're integrated across the stakeholders. Science obviously is one of the biggest stakeholders in why we're going to the moon. And so that's the job that we carry. I do also want to thank Julie Robinson at this point. Some of you probably know her. She's spoken to the survey community. She has departed human exploration and taken a role in the Science Mission Directorate as the Deputy Director for Earth Science. A great opportunity for her, but I do want to thank her. Many of you may not be aware of what all she has done for survey because she has been doing that at headquarters. but she did a tremendous job fighting for the budget from the human exploration side to make sure that we have this partnership with SMD going forward. So you may not know that you need to thank her, but I would like to encourage you to if you ever run into her, because without her, it probably would have been hard for us to proceed forward. Where does this all start? Well, the White House Space Priorities Framework that was released late last year very clearly stated that the United States will maintain its leadership in space exploration and space science. Science is a critical pillar for why we're exploring the solar system to help understand our place in this universe. You may have seen released from NASA recently a set of objectives. And in fact, Pam Melroy's group has been engaging the community. We asked for feedback from the community. 2 weeks ago, they held a workshop in Houston to collect feedback from the community. And most of my colleagues from my group are actually in London right now with the second of those workshops collecting inputs from our international partners. I do want to just point out, I won't read all the words. I do want to get slides in here so that you all can look back at them at any point. But the number one pillar here on this chart is science. And that is the way the agency is approaching this. So I want to make sure to make that very clear. That message is given to our directorate. The science is the reason we're putting this architecture together. But what does that mean? Well, what I'd like to do is walk us along the path of how we get science into the architecture. It starts with understanding the objectives. As I look around the room today, again, very happy to see all of your faces. I see a number of senior members of our community who have spent many years ensuring that these objectives are documented in a series of documents. And I want to be very clear that the objectives we are setting today trace to that documentation. Here you can see the science objectives. I think most of you are probably familiar with them. Many of you had a hand in helping craft them. And this is what is traceable to the Artemis 3 Science Definition Team Report, which is the document that our directorate traces to. So all of that effort over the years collecting these inputs is very critical for us. It's also critical for us to understand that we put objectives in documents, but those objectives evolve as we learn, and they will continue to evolve. And this is an evolving community, an evolving architecture to make sure that we can meet evolving objectives. Oops, I went a little too far. It's not only the science, though. There are other stakeholders. I know Clive will be speaking shortly about ISRU. These are the objectives that we carry for the Space Technology Mission Directorate. But I do want to point out that although these are different objectives, there are commonalities. I think Clive may very well talk about this, but understanding the resources on the surface of the moon requires understanding those resources, which requires the same types of measurements that the science community is interested in. This is all about collaboration between the stakeholders and between us and all of the stakeholders to understand what we are trying to accomplish. We also have objectives from our directorate, understanding what our crew will deal with and what our hardware will deal with as we endeavor to travel farther and spend longer periods of time in space. Understanding radiation, confinement, how to operate farther away from the Earth. How do we deal with changes in gravity? If you are in a low gravity environment for a long time and then you go to the surface of the moon and are expected to do jobs right away, how quickly can we expect to do that? These are the types of objectives that we need to consider. Now, our directorate carries a series of documents at the directorate level that drive straight out of the NASA Authorization Act, of which we number these. And they carry our old designation, HEO, Human Exploration Operations, because that's where they were written. Our office is tasked with leading several of these, and my group in particular leads the HEOMD 006, which is the utilization plan. The utilization plan is where we document the objectives for our directorate so that all of our engineers and technologists know what is the driving force behind what they're trying to build and how to integrate it. This is a little more about that document. As we write the contents that go into this document, They are often released to the public. I wanted this slide in here so that you can look at that link. That link will show you the current content in the utilization plan that is publicly available. One of the keys is within the HEO 006 utilization plan, we have an annex that is specific to each Artemis mission. That's where we will document the goals and objectives for that mission as the stakeholders bring them to us. So that is part of the job of what our office carries, and that will trace to those objectives that we document at a higher level. This is an example of the initial objectives that were put into the utilization plan. And you can see they don't go into specific detail. That's where we work the annexes for each mission. What they do is kind of set the stage with a goal of not eliminating the options to do any of the science that we want to do, but also clearly documenting and traceability for our engineers. The key here is that these objectives are not owned by our directorate, by human exploration. They are written and owned by the stakeholder organizations. They can change these at any time. For instance, when a decadal comes out, or when we work through a new report that maybe carries significant weight with respect to what the community wants to do. When we learn something new and we need to change those objectives. This is where that happens. The directorates will tell us when they want to do that, and we will change them accordingly. And therefore, the approach to addressing those objectives will also change. The other thing that this does is it helps us highlight areas where we will need to integrate across multiple programs. Some of the objectives that we have listed are not something that we can just go do in Artemis 3 and be done. They're going to require a significant amount of work, probably across multiple missions, across multiple vehicles or programs. They might actually require us to go learn a few things first at the moon before we can go do those jobs. So these are some of those examples. I'll just give cite one of the examples here is operating in cold and shadowed regions. If we do want to bring back an honest to God ice cube from the lunar surface, we have to learn how to do that. We have to learn how to carry it between multiple vehicles and keep it preserved, preserve the integrity of that sample from the environment from which we took it. We're learning a lot from ANGSA. I was just talking to Chip about how to develop the containers that will carry them. But this is not something that you just go do in one mission. We have to learn together, and develop requirements that help us meet those objectives. Around that, we build the architecture. So we develop a series of vehicles, capabilities that will help us achieve those objectives. I know I've shown many of these slides before. I'm kind of putting these together in a single slide here, but the vehicles that will carry our astronauts, the vehicles our astronauts will live in, will land on the surface, will drive around the surface. All of these require development, and they need to understand what it is we want them to be able to do so they can properly develop those systems. And that's where we are today. We're trying to make sure that the requirements on these systems match up with the goals, the objectives, what we want to accomplish. Now it is getting real. Artemis 1 is getting close. Now I'm gonna go ahead and ask myself this question. When's Artemis 1 gonna launch? Simple answer, when it's ready. This is a test mission to demonstrate that the SLS and the Orion will work and be able to safely carry our astronauts so that we can move forward with Artemis. It will fly when it is ready and we can properly demonstrate that. It's getting close, okay? We are getting close. Announcements are coming out. We're learning about this as we roll it out for wet dress. We were asked at one point, well, how many times did Apollo go? It's easy to look back and think about things in what I like to call a romanticized manner. It all went great. And even the things that went wrong went great. We figured them out, right? But this is reality. It wasn't like that. It was hard. Things didn't go right. And we're learning about it. We're learning how to get this vehicle prepared to launch. The Saturn V had several steps, just like what we're seeing with Artemis 1 now, as did the shuttle. It didn't just roll out and launch. Okay, so we're right in line with where we are from what we've learned in the past. This thing is going to go off soon. And when it does, we are definitely on our way, and this is getting real. I'm not going to explain this in detail, but Artemis 1 will go out around the moon and come back. It will demonstrate everything we need to do in order to take our astronauts out there, which we will do when we launch Artemis 2. But it isn't just a test of those systems. We are taking science along. The integration between meeting objectives and developing the hardware is underway. We will carry CubeSats that will go into space, that will observe the moon, that will learn about navigating in deep space, that will help us understand how life responds to the deep space environment. Also within the Orion, we'll be doing very similar studies, characterizing that radiation environment, understanding how life responds to it. These are all critical lessons we need to learn in order to ensure the safety of both our astronauts and our hardware so that we can go accomplish the objectives that have been set out for us. Artemis 1 tests out that system. Artemis 2 will carry our astronauts farther than any humans have been from the Earth. That will lead us to Artemis 3, which will put astronauts on the surface. Meanwhile, we'll be developing a system that orbits the moon, a laboratory that helps us again understand more about that deep space environment and offloads some of the hard work from the systems that are going to land on the surface. This is a rendezvous point for our hardware, for our vehicles coming from Earth, going to the lunar surface, coming back up. It's a laboratory to help us understand what that environment is. One important key about this slide that I want everyone to make sure everyone doesn't miss is that up there in the top left corner is the Lunar Reconnaissance Orbiter. That spacecraft had the job in 2009 when it launched, learning enough about the moon so that we knew where to go and what to do. It did its job. It did its job, maybe not on the timeline we were all hoping for, but it did its job. It put us in a position to do what we're doing today. Just a couple of things about what we're developing. I've talked with many of you about the system we're running now, the business model. We're putting out RFPs to build these systems. We've talked about the HLS. We're preparing to release an RFP soon for the LTV, a lunar terrain vehicle to drive around the surface. This is the most recent one that's been given an award for our suit systems. NASA selected Axiom Space and Collins Aerospace to be the companies that build our next system of suits. These suits are going to be what our astronauts wear when they're doing the jobs we're outlining with these objectives. It's not just about the suits, though. Part of that contract includes a number of aspects that are important to what we're doing. And I'll note at the bottom here, one of the most important is developing the tools and the curation capabilities to get those samples home for us. So as we learn, still learning from Apollo with the ANGSA program, that helps influence what we're going to do as we develop these systems. So in partnership with our commercial partners, we're moving forward and getting these systems developed. Now, after we get that first landing in Artemis 3 with astronauts on the surface, we'll continue a buildup on the surface. The goal here is to increase capabilities so that we can accomplish those objectives. We'll build up the gateway. We'll build up resources on the surface with a goal of mobility, finding new places that we want to go to meet the objectives. All of this works together, and all of it is influenced by knowing what we want to do. The gateway already has payloads designed to fly with it, again, to help us learn about the space environment. So even the early launches for Gateway will be carrying science. You all are a key part of this. Survey is another area where we're collaborating with SMD to make sure that we're learning what we need to learn. It's really hard to capture everything you all do in one slide, trust me, especially when you have to explain it to all of your managers. But Greg and Christina, I think, have done a pretty good job here. And I'd like to make it even harder on us to make a slide like this over the next few years as we get into Can 4. I also want to point out that we're getting our ground-based analogs up and running. Many of you supported Desert Rats during Constellation. We're starting those back up. We also have a variety of different analogs that are going on, and we're working hard to coordinate across all of them. And we'll be able to talk more about that in the future, but these are starting to get up and running again. So one last parting point here is, this is why we're going. This is where we're going, and we want to address the objectives. Again, just this morning, we talked to some of our early career folks. So if you are working on a degree right now, or within 5 years of getting your degree, can you just put your hand up? Everybody up here in the front rows, turn around, make sure you look at those folks. Okay, we told them that at this meeting, they should go and find you all and talk to you. So I'm challenging you to talk to them, okay? Because all of this, all of our frustrations and struggles, all of our annoyances as we've gone through this process over the last years, few years, decades for some of us, it doesn't mean anything if those folks don't carry this forward, okay? They're the ones who are going to be deciding where we go in 10 and 20 years from now. All that knowledge you've got in your head, I know we're all trying to get it documented, share it with them, okay? Because again, why are we doing this if they don't take it from us and take it farther than we ever dreamed? Okay, so this is getting real. Opportunities are coming. Please apply for them when you see them. And with that, I'm going to hand over to Sarah Noble to talk a little bit more about this perspective from the Science Mission Directorate. So thank you for your time.
Fantastic. Great. So Jake did a great job of sort of setting the stage here and showing how the agency is working towards Artemis, and he's right. Like Jake and I have been doing this sort of buddy comedy roadshow for a few years now. And we keep telling you things are coming, but now, like, for real, like, things really are coming. And so he's going to sort of set the stage what the agency is doing. I'd like to go a little bit deeper and talk specifically about how we are preparing to do the science. Starting with how we are structuring the science team. So, a reminder, I don't need to remind you all, but it has been 50 years since we've had humans doing science on the surface of another planetary body, as we celebrate the 53rd anniversary of Apollo 11 this year. And so we're not starting from scratch here, but Artemis and Apollo goals and implementation are different. And so we are also not just redoing Apollo, right? We're building on that, on the things that we learned from Apollo and even from Constellation. But the lunar science community, look around, is very different than it was during Apollo. It is much bigger and broader. And we've had sort of 50 years to think about what it is we want to accomplish at the moon, right? And we have this global picture now, thanks to LRO and our other orbiters, to understand where we want to go and what we want to accomplish when we get to the moon. But NASA is also different, right? We have a large cadre of talented scientists among our civil servants. Some of you are in the audience today. And that really wasn't the case during Apollo. The numbers were small then, but the advantage of that is that we've had folks working on Artemis even before Artemis had a name, right? And so we have people sitting in the room, sitting in those meetings, representing science and making sure that as we build this architecture, we are building it to do the things that science needs it to do. And also our approach is different. Jake talked a little bit about the sort of commercial approach that we are taking with Artemis is very different from the way they did things with Apollo. It's also a much more international approach. We've got, I don't know how many, 24 signatories now on the Artemis Accords. We're not going to do this alone. We're going to do it as part of an international community. And so, our response to that, has to change as well. I'll talk a little bit more in detail here about how the science team is going to be put together, but it will be composed of both internal NASA scientists. As I said, we have folks on the ground now, as well as competed roles. We are working on getting those on board. And I will note that the current plan is relevant only for the sort of sortie phase of Artemis, these short standalone missions. And we're going to evolve these plans as we sort of enter into the sustainability phase that Jake was talking about with the second swoosh chart. Yes, sweetie. Sorry about the cat. I do want to note that this is a work in progress, but as always, my goal is to be as transparent with the community as I can. You can sort of think about the science team as being composed of 3 different components. The first is the internal team, right? Again, NASA scientists who are already working on Artemis. Many of them have been working for years to help build up those capabilities within the agency. Currently, those folks are largely funded through Jake, through the human side of the house. But as of next fiscal year, they will be transitioning to SMD funding. They will be our team. And they will be conflicted from competition. I'm going to talk about some of the competitions we've got coming up. those folks will not be allowed to compete for any of those competed roles. So if you have asked them to be on your team and they turn you down politely, that's probably why. We are working on a competitively selected geology team. There's a placeholder that came out in Roses in February. We are working on drafting the final text for that, and it will be out when it's ready. Those will be for teams, roughly 10-ish team members. But if you miss your opportunity, that chance, we do anticipate a second call for participating scientists, closer to probably about a year or so out from the Artemis 3 launch. And we will repeat this process then for each landed mission. So we'll bring on a new competitively selected team for each landed mission. And then in terms of payloads, I apologize again for the cat. I don't know if you can hear her screaming, but she is quite loud. For the payloads, we also have a placeholder out currently in Roses for payloads for the first couple landed missions, Artemis 3 and 5. As well as for the Lunar Terrain Vehicle that won't be ready for Artemis 3, but we do anticipate wanting to put science instruments on that Lunar Terrain Vehicle, and so the placeholder for that is also out now. I want to talk a little bit about what the roles are of this internal versus competed teams. So again, the internal team right now, largely their point is to make sure that the architecture and systems are being built to support science. They are embedded on boards and working groups across the agency. They're reviewing documents. They are providing some rapid responses to the requests and the queries that we're getting from across the agency as folks are building various components of the architecture and have questions about what science needs. As we go along and we get the competed teams on board, they will serve as the interface between NASA and those competed teams. They will be leading the classroom, the field, and the ops training for the crew. They will also lead the operational training for those competed teams as we bring them on board. And as we go between missions, as we sort of build up between Artemis 3 and 4 and 5 and so on and so forth, they will provide program level strategic planning, mission to mission continuity to make sure that we aren't missing things as these various teams come on board and leave, and that they are there to represent the entire community and not just the competed team. Meanwhile, the competed team will be there to focus on that specific sortie, the Artemis 3 sortie or those after. They'll develop the mission science objectives for that sortie, including the field science goals, traverse planning, sampling strategies, support training as needed. They'll provide real-time operations support, help with preliminary exam of samples along with our curation staff, and write the post-mission geology report. We introduced these folks already at our LSSW in May, but for those who didn't catch that, I wanted to make sure we had a chance to introduce them again. Many of them are in the audience today. Some of them are in Iceland, but they are around and they are members of this community. Most of you know many of these folks. So we've got our training and ops team, including Cindy Evans, who leads our astronaut training, Kelsey Young, who has been working with the flight ops directorate for many years now, sort of building up trust and making sure that we have strong communication with that group. And Trevor, who is our EVA hardware and testing integration lead, making sure that the tools are being designed to support science. Then we've got our samples group, right now led by Barbara Cohen as our sample integrity lead. We are in the midst of trying to find a contamination control scientist. Please keep your eyes peeled. That call should be going out soon. I think in the next couple of weeks. And we unfortunately recently lost our Artemis curation lead. Julie Mitchell left the agency. Brian Ziegler, who is our Apollo curator, is in an acting role at the moment, but JSC is looking to replace them. So there are some opportunities out there if you guys are interested in serving on this team. Please keep your eyes peeled for that. Una. And then finally, we've got our planning we've got our planning and data group, Sam and Noah. Some of you may not know Matthew Miller, but he's a wonderful software lead, and the three of them are making sure that we have all of the data that we need for Lunar. for all of our needs for landing sites, for planning, all the things that we need data for. And then finally, our payloads lead, Renee, who will serve as sort of the interface between these payloads as the competed payloads as they are brought on. So that's the team. I want to talk a little bit about some of the other things that we are already doing right now, including training. And so this is a slide I stole from Cindy, but to show you that we are actively working on training. So, and this is not new. It would be awesome if every astronaut was a lunar scientist, but they come in with all kinds of backgrounds, but don't worry, by the time we send them off to the moon, they all will be lunar scientists. And so we've started actually several years ago incorporating geology training into their basic astronaut training. And so they all go through a basic geology course as part of their initial astronaut training. And then in the intermediate years, we try and find opportunities for them to get out into the field, to get some real hands-on coordination with, get some hands-on opportunities. And in fact, I know a number of survey teams have brought astronauts out with them into the field, and it's a great way for them to really understand what it is that a geologist does out in the field and get some hands-on experience. So we try to get them out into the field as often as we can. But we are now working on this phase 3, the mission-specific training for Artemis. We're right now in the midst of writing lesson plans and curriculum development to try to get ready for those astronauts as they are named. And Jake talked a little bit about analog testing, and we really are ramping that up right now. In all sorts of ways. We are testing, just going out into the rock yard at JSC. We're testing on the NVL, the Argo system, which lifts the sort of weight off you, so you can imagine what it's like in 1G. But we're now really building towards these larger tests. And Jake talked about how Desert Rats is being reinstituted, and they sent out a sort of Desert Rats Lite last year, but this year there will be a full-up Desert Rats test that science will be very involved in. And we're trying to start to learn how do we do our science ops, and getting out and doing these analogs is the best way to do that. We actually have a competed science team that is participating both in Desert Rats as well as Jet 3, which is a very Artemis specific. Desert Rats will focus a lot on pressurized rover operations, and that's fantastic, and we need to understand those, but we have more immediate needs for understanding sort of the walking traverses that will happen during Artemis 3. And so we're doing also an Artemis 3 very specific analog test this summer, and we'll have science participation in both those tests, trying to understand a lot of the things that came out of the League analog objectives for Artemis Special Action Team last fall, including understanding background structures and communications and software and how all of those things work together, understanding science ConOps, understanding the lighting conditions, right, which are very different at the South Pole, and how do you do geology under those conditions, and what kind of lighting is best. And so we will go out in the middle of the night, and we will bring our own sun with us, and we will try and test out to understand how we actually do science under those conditions. And so these activities are really critical for us. We have a lot of objectives that we need to work on, and this is the best way to do it. And so I do want to note that again, we competitively selected team this year. We will do that again for next year's calls. And so that call is on the street right now. It is open to US persons, which means citizens and green card holders. The reason for the restriction there is that you'll have to deal with a lot of NASA IT, and that becomes a big problem for foreign nationals. And so we've had to restrict it slightly. But we are trying to be as inclusive as we can, and we have actually allowed even senior graduate students to participate in that call. And so if you're looking for opportunities to get involved, like, this is really important. This is really critical stuff for Artemis. And if you really want to get your hands dirty and help us understand how to do this, this is a great opportunity. I do want to talk a little bit about how we are getting input from the community. I feel like I hit this horse a lot, but it is all very important for us. As I mentioned this morning to the students, Jake was talking about how we were talking to the students this morning. And one of the things I said to them was, it's not NASA exploring the moon through Artemis. It's us. It's our community that's going to have to do this, and we need all of it, all of the community. NASA can't do this on our own. We need the science community to support us and provide the input in order to accomplish the things that we want to do with Artemis. And so talk a little bit about the ways that we're getting input. And really the most important one right now has been the Lunar Surface Science Workshop Series, which I'm sure many of you are familiar with, but I keep running into people who've never heard of it. And so I wanted to give a little advertisement for this series of workshops that we've been doing. It was intended as an in-person workshop in April of 2020. That obviously didn't happen due to the pandemic. And so we started doing these sort of monthly workshops to work through individual sessions from that meeting. And it's sort of taken on a life of its own since then. We've now had 18 sessions to date. We have more in the works. Each of these sessions, we bring in members of the community to help us lead. And also sort of annually, we've been using it as an opportunity to provide information to the community. So it's more of a two-way conversation. Yes, we need your input, but we understand that we also need to tell you guys what's going on so that you can be most effective. And so hopefully it's a two-way street. Each of these workshops generates a summary report. You can find it linked from the survey website. And actually all of the talks are recorded. And so if there's an interesting topic you're interested in and want to go back, all of the talks have been recorded and are there for you. We post the draft reports, get a community comment, and then finalize them. We are working on ways to make those reports more available. Right now, they really just exist on that website, but we are thinking about ways that we can make them more available to the community. So if anybody has any ideas, please come talk to me. Here's just a quick, and I'm going to soon need to go on to a second page. I think we're running out of space on this, but just to give you an idea of the topics that we have covered, including the early ones, which were part of that original workshop plan. But since then, we've had either calls from within the agency, like the Planetary Protection, which is the Planetary Protection Office, came to us and asked us to do, and the structuring real-time science support, which is something that we just felt like we needed some input on, as well as things that have come from the community that if they've said that, oh, we really want to talk about this, like the Future Eclipse landing sites, the recent one we had just last week on ISRU. So it's a little bit of a two-way street. Some are bubbling up from within and some are coming in from the community, but we have so far not run out of topics. And so if you have other topics, please feel free to let us know. We have a number of our own that'll be coming up over the next few months too. So we have no intention of stopping this. Seems to be very useful for us and for the community. Survey, of course, is another way that we get input. Jake talked about how important our relationship is in building bridges between science and exploration, and that is the purpose of Survey, and it remains that way. And we get inputs sometimes directly from the teams, from the focus groups. There are Survey-sponsored workshops, and so we look to Survey often for input. As well as League, of course, our community group, and you'll hear from League, I think, is it tomorrow? I'm not sure, it's later this week. We've put a lot on League over the last few years in terms of asking them to put together special action teams to provide us specific information about various topics, including the Lunar Critical Data Products Special Action Team. I already talked about the analog objectives for Artemis that is already bearing fruit. We have been using that as our Bible as we're getting ready for our activities this fall. And you're going to hear later this week about the continuous lunar orbital capabilities special action team. We're very much looking forward to those results as we move into an era beyond LRO. And then, of course, I just want to give a quick plug for the upcoming League meeting at the end of August. We will provide some more Artemis updates then, and we are, of course, always looking for input from the community at those meetings. And just one last word, I wanted to say a little something about the Planetary Decadal. You know, this is a big deal. Decadal is very important to us as a community. We put a lot of effort. It's about 3 years to put one of these together. And so we're very thankful for the folks that were involved in that and that put a lot of time and effort behind that. And you know, this is the first time that they have actually been considered human exploration as a topic in the Decadal. And they came out in favor of human exploration, which is fantastic. And said that, you know, human exploration is actually really important, and it is a great venue for doing big science. I'm not going to say too much here because you know, we are currently preparing our 90-day response. Those should be out fairly soon. But I do want to just mention that, you know, as we get those statements out, that's our only real formal response to the academies, but that is just the start. That is not the end of our response, and we'll continue to update the academy and the community as we incorporate those recommendations into our planning. And I think that is my last slide.
Okay, so we have just a couple minutes for a question, and online participants, you can put your questions into the chat or you can raise your hand. And so does anybody want to ask Jake or Sarah a question? I mean, this is going to be a first. Who? Stand up, please. Did I hear anything? It would be helpful so the people online can hear. Okay, let's do Clive and then Renee.
Hello, Renee Say is there from Survey Australia. It's been 5 years since I had the pleasure of saying hi and being here. So as here representing Australia with respect to Survey, how do you see the international role played out within the auspice of your directorates, particularly thinking around Australia's Moon to Mars support for Artemis? I'd love to understand how we can support these endeavours with a particular focus on science. Thank you.
Sarah?
You want to start? You want me to start? Okay. So from a science perspective, yes, certainly we have thought a little bit about how international folks can play into the things that I was talking about. Certainly you're welcome to be on teams that are proposing to the geology team call. You are also, although we are not accepting international PIs, but you're welcome to be team members, co-Is on those teams. You're also welcome to participate in our participating scientist program. Well, that call will be open internationally. And then in terms of payloads, I think we may have to wait until that payloads call comes out, but there will be some international participation in that as well. I'm not exactly sure what level.
Fantastic. Thank you. Keep us in mind.
Yeah, and Renee, I can also just add to that. I did mention that a lot of my office is over in London right now, collecting feedback from our international partners. Sarah mentioned the Artemis Accords, which a number of nations have signed up to. But ultimately, we're negotiating with our international partner agencies. You know, a point I guess I didn't make very clearly is that what we're doing with Artemis for NASA is basically trying to get the foothold on the moon. And we're really looking to partnership with companies and especially our international partners. NASA can't build all of it. And so we will need that partnership. And I can say for a fact that we are negotiating with international partners right now about what's the next element? What makes the architecture grow to the place that it can do those objectives or those objectives? So those conversations are underway.
Hello, this is Clive Neal, Notre Dame. Question for Jake. When's the next human landing after Artemis 3?
Well, thanks, Clive. As always, love your questions. You know, these questions are not easy and they're budget dependent and these things change over time. As I said for Artemis 1, I know you won't ask Artemis 1 because I already asked myself, but the answer is always when we're ready to do it safely. Now you're talking about 3-4 missions out. It depends when Artemis 1 launches. It depends when Artemis 2 launches. What we're hoping to achieve is a cadence of once per year. Are we going to realize that by Artemis 4? I don't know. But the goal here is to get into a position where we can land every year and increase the amount of time that we spend on the surface by adding infrastructure to the surface. It would be speculation on my part at this point to give you a date for that. But stay tuned to what does launch, because that will impact when these will launch.
Understand that, but how many SLS launches are needed for Gateway? Let's do it that way.
So now you're asking about the sequence, right?
Aha.
So sequence also will end up being budget dependent and dependent upon how quickly things are developed. So I love you, Clive, but you're not going to pin me down to saying
Not
numbers
trying to
up
pin you
here on
down.
dates. Okay.
Really not. Well, maybe a little bit.
But all of this is complicated, right?
Oh,
And
yeah,
as
I
Renee's
realize that.
question, international partnerships come online. We have a plan, and that plan will evolve based on what we can accomplish and when things come online.
All right. Thanks.
Okay, I'll make it quick-ish. Ben Bussey, Johns Hopkins Applied Physics Lab. Sarah, your talk talked about, it mentioned a sortie phase for the geology teams, which implies not going back to the same place, not building up infrastructure, etc. What is the current plan for how many sortie missions to the polar regions before a site is picked and we actually get what I like to say is a foothold, not footprints?
Yeah, I'm going to turn that to Jake too.
Yeah, very similar to Clive's questions. I mean, these are important questions and we are asking ourselves those. Again, it depends when capabilities actually come online. We can show you artistic renditions saying this, this, and this, but those things have to be built and they have to be budgeted for. And so what I choose to do is focus on what we can accomplish with what capabilities are online at a given time. There may be sorties for several missions, I don't know. But when capabilities come online that can start to connect them and give us a reason to go back to the same place, we would start doing them. But again, they have to match up with the objectives. Human exploration will go where we need to go to meet the objectives we've been given by our stakeholders. So that's what we're looking to accomplish. So it kind of really depends, and it kind of depends, the first piece of infrastructure that really starts to connect our landing sites would be the lunar terrain vehicle. If we use that vehicle to drive between landing sites so that mobility is increased, that would be the first. There will be some range depend on what capability we actually receive. This is part of the other difficulty in answering these questions. We're writing requirements and putting out RFPs, and then our companies are competing for them. I can't tell you what the capability will be of any of these elements until we actually award a winner and can spend some months working with them to understand. So it's really difficult to say we'll do this by here until we know what the capabilities are and what the sequence of those things coming online will be. I did want to say one last thing. I've given a number of briefings with Luna, and I will say that without a doubt, Luna is better at diffusing tense situations than anybody else that I have met yet. So always a pleasure, Luna. Thank you.